Welcome to my channel, and today we'll be looking at how to use a lumped battery model to do a time-dependent parameter estimation. We'll make a plot of the model and experimental cell voltage with respect to the OCV. Also, we'll look at the ohmic charge transfer and concentration voltage losses, look at the plots of all these with the experimental and the OCV, look at the predicted OCV, also look at the voltage of the predicted OCV using the parameter values. So during this work or tutorial, if there's any question, kindly drop your question in the comment section. I'll do well to answer every question that you have. Thank you, and please let's follow to the end. Thank you. We begin by opening a new model. We click on our model wizard. Then we choose our space dimension, which we'll be working with. So we select 0D. Then we go on to select lumped battery. So we open electrochemistry, battery interfaces, lumped battery. Then we move on to select our steady. We select time dependent steady. So it brings us to our interface here. So you can see. So we go ahead to add our parameters. We'll load our parameters from our file. So we go on to click here to load, which brings us here. Then we select our parameters. So we select this for our parameter. We go on to double click. Then it adds our parameter, loads our parameters. So we go on to add our variables as well. Which will load from a file. We select this and load. Now we have our parameters. So later we'll define all these variables so that they will turn from this color to black. We want to add table to our results in here. We want to name it as load cycle table. We want to import from here. So it's just after the capacity loss, we use parameter estimation just after this. So this is what we choose. and click on open to load our file. We go on to definitions, then we want to add, before that, we want to add function interpolation to this, which we will name as E and I versus T. Then our data source will be from result table. It will be load cycle. Our function name, we want to change this. And this as well. I want to change the arguments to S and the function argument S. Go to our variables and we realize that all these unknowns have been defined, now turn to black, which is very, very important, because if they are not identified or they are not defined, we'll not be able to compute our work. So we check this section as well. We check the applied current, which we'll be using. We want to define it. It's this. We want to also define the battery cell capacity. And also we want to define the initial state of charge. Okay. We go on to check the cell equilibrium potential. We want to clear this table in here. We want to load from file. We want to choose load our data from file in here. So this will be our file that we want to load. I want to change this temperature to T. We move to the voltage losses. Where we check all these sections. We want to include concentration over potential. We move to steady, then we want to make this steady load curve simulation. We move to our time dependent, then we want to change our range values. In here, we want to use user controlled and set our relative tolerance to very smaller decimal. We go ahead to compute our work. Which gives us our results. We want to set this as our cell voltage title. We want to also change the position to our right for our legend. We move to our global one. And we want to set this as our modeled cell voltage. Move to our global 3. We want to put an expression, go to our definitions, our variables, and we choose this. We want to make some small edits on the manual axis. Change this to 305. But we change here to 3.35. Why am I doing? Change to 4.2 in here. We update. Move here. Move to our cell stage of charge. Then we add a 1D plot group. That'll work. Then we'll name this as voltage losses and load, which will go ahead to add a global plot, add an expression, now come to our over potentials, where we select this ohmic over potential, double click to add. So we go on to add another expression. We add one more expression, which will be the activation over potential. We add also the concentration over potential. To this. Once we've added these three expressions, we go on to set the parameter to an expression named as t. We go on to update our plots. We see our various over potentials shown in here. You can see our ohmic over potential, activation and concentration over potential over a period of time. We want to go on and add the global plot. We'll set this expression as the cell current. We choose this. Then we go on to set the parameter. It's time. We want the line to be dotted. We want the color to be black. We want to plot this. So as you can see, it has been updated on our plot in here. You see the cell current in the graph. Go to our voltage. Take the title off. Want to know the y and x axis. Want the y axis to be our over potential. You set our y-axis to be over potential. And we want to add our global 2 to it. As you can see, it's been updated on our plots. You see our overall potential over a period of time. We want to edit our axis. So it has been updated after making some editing on our x and y axis, and how our plot has been beautifully plotted over here. So we go on to our component 1 to add physics, which we want to do a general optimization. We want to add optimization to this. So we've added our optimization, and we want to do some other, include some other optimization to our work. We want to optimize our work. We go on to add our global least squares objective, which we'll be using for optimization. Our data source, we want it to be from the results table. We want our results should be load cycle table. Our time column should be TS. And our model expression for this should be so. We want to uncheck this. We go to our voltage losses. We want to set our diffusion, our temperature to T. We want to set our ohmic over potential eta. We want to set our exchange current density. We want to set our diffusion as well. Go on to add another steady. Which will be a time-dependent steady. That will be our parameter estimation. We want to uncheck our default plot. We want to add optimization. Set using this optimization. I want it from least square objectives. Come to control variables and parameters, where we want to add about 3. We'll make inverse diffusion. So we set our scale 0, 1. So we set them as such. We go on to our definitions to add a global variable proof to our work. Our expression will be eta which will go on to duplicate this. It will be this. We go on to duplicate it again the 3rd time. Change this to go to our parameter estimation and want to compute. If you find an error, so there was an error because Comsol detected that this variable is undefined. So we actually go to where this variable is located over here. Then we make sure we input it for this is supposed to be, it's a small l and b dot e caps E underscore CL. So kindly note that this is an L, small l. So can go ahead to compute, which will solve our work for us. It takes some time depending on your computer processor. Okay, so good. That's been able to compute our work. We move to our cell voltage section, where we select our data set to be parameter estimation 2. We'll plot well. So there is some changes. Now work. Then we move to voltage losses. Also, we set our data set to steady 2 parameter estimation. And there too, you can see some changes. Go to optimization. We go down to output, power solving. We check the plots section. Then we go ahead to compute. Okay. We patiently wait for it to finish computing. Okay, so we go to our tables and we add a table which we'll name as our full load cycle. We want to import our data from here. We go to full data, look for full data. Okay, so there's our full data. So this is what we select for our work. Go on to global definitions. Add another interpolation, which we'll name as E N I S T full. So our data source will be from result table. Table will be full load cycle. We'll go ahead to name our functions, what our functions will be. E cell, exponent, full. Let's go full. It's 2. Units is S in here. Go on to our variables. We want to duplicate where we change one section to full. No, not that. Change this part. We add full. This section to as well. We change. We add full. This section. We go on to add another steady. This will be a time-dependent steady, which we'll call full load cycle. Predictions. We want to change the time. 1 to 600. Want to use user controlled. It tolerance, you want to increase, reduce it. You want to modify the model. Disable first variable. We disable optimized. We also change the variables settings to user controlled, where we change the steady to parameter estimation time dependent. We don't want to generate default plots. Move to variables too. Steady one, time dependent too as well. We want to also disable both variables too and optimization. We want to disable them. Steady too, so we want to do same. Disable variable 2, but we leave the optimization for this section. So we can go ahead and compute duplicate our cell voltage. We call this the full cycle prediction. That'll be the full cycle prediction. Data set should be the full load cycle prediction. We want to do some manual changes to the x-axis. 610. I want to change here to, I would like to plot, see how it changes. I want to change the legends to lower left. As you can see here. Go to global 1. And we want to name this as predicted. Any changes. So you're able to see our predicted ones. We go on to add global valuation. Which we'll name this as standard deviation steady 1. We will have to put in an expression for this, which will be small lb dot cops e cell xp. Go on to add, the operation should be standard deviation we want new table. It has evaluated it for us. We're going to duplicate this. Name this as steady2. That will be parameter estimation, which we'll use. And we will also evaluate that data set. Go on to duplicate same, which we'll name 3. We want data set to be full load cycle 3, which we'll evaluate in here. So we want to do a time selection. Want to make a range 0 to 1 6 7 1. Let's evaluate that gives us our results. We've been able to do an evaluation of this work to see within time range of this what this evaluation will be. So this brings us to the end of this work section. And thanks for following till this end. If you have any question, kindly drop your question in the comment section.